Introduction to Spring Messaging. Spring Messaging provides features for building message-driven applications in the Spring framework. It supports different messaging systems and models, abstracts messaging APIs, and offers annotation-driven listeners for message processing. In this code snippet, we define a Spring component message receiver that listens for messages on the messages queue. The @JMS listener annotation is used on the receive message method, indicating this method should be invoked when a message is received on the specified queue. The method simply prints out the received message to the console. Spring support for messaging with JMS. Java Message Service (JMS API) provides a way for Java applications to create, send, receive, and read messages. Spring Framework simplifies the use of JMS through its abstraction layer that handles resource creation and maintenance. Using JMS template simplifies the production and consumption of messages. In the provided code, Message Sender is a Spring component that uses JMS template to send messages. The send method takes a destination, the JMS queue or topic name, and a message, a string to be sent. JMS template.send method is used with a lambda expression to create a text message from the session provided by JMS. The @AutoWired annotation is used to inject the JMS template dependency into the message sender bean. This shows how Spring can abstract JMS usage for simpler messaging operations. Using @EnableJMS and JMS Listener. In Spring, @EnableJMS annotation enables detection of JMS Listener annotations on any Spring-managed bean in the container. The @JMS Listener annotation marks a method to be the target of a JMS message listener on the specified destination. The code snippet consists of two parts. The first part enables JMS processing in the Spring context using @EnableJMS attached to a configuration class. The second part marks a method as a JMS message listener using @JMS Listener. The destination of the messages to be consumed is specified as queue.sample. When a message is received, it is printed to the console. Spring support for AMQP with RabbitMQ. Spring provides support for Advanced Message Queuing Protocol (AMQP) with RabbitMQ, a popular open-source message broker. The Spring AMQP project allows developers to integrate RabbitMQ as a messaging option within their applications, simplifying the process of sending and receiving messages through a message broker. The code provides an example of a Spring Boot application that uses Spring AMQP for handling messages with RabbitMQ. The @EnableRabbit annotation at the class level is necessary to enable support for RabbitMQ messaging with Spring. The Rabbit Listener annotation is used on a method to indicate that it should be invoked with messages from the specified queue, here named example.queue. Upon receiving a message in this queue, the receive message method is called with the message payload, and the message content is printed out to the console. Spring Integration Basics. Spring Integration is an extension of the Spring framework that supports the well-known Enterprise Integration Patterns, EIP. It allows for lightweight messaging within Spring-based applications and supports integration with external systems via declarative adapters. Below is a simple example that demonstrates how to configure a message channel and a service activator. WebSockets with Spring. Spring Framework provides support for WebSocket that allows for two-way communication between a client and a server. This is particularly useful for developing interactive web applications where real-time updates are required without the need for constant polling. With Spring, you can easily set up a WebSocket endpoint and use messaging protocols such as Stomp to handle communication. The given code snippet defines a simple Spring controller with WebSocket messaging capabilities. The @controller annotation marks the class as a Spring MVC controller. The @message mapping annotation indicates that the greeting method should be invoked when a message is sent to /hello. The @sendTo annotation specifies the destination to send the message to after the method processes it, which is /topic/greetings. Upon invocation, the method simulates a delay, then returns a greeting object that will be sent to all subscribed clients as a message. The HTML_utils.html escape method is used to sanitize the input to prevent XSS attacks. Introduction to Reactive Programming. Reactive programming is a programming paradigm oriented around data flows and the propagation of change. It involves developing applications that are fully reactive and non-blocking, capable of handling a large number of concurrent operations efficiently. In Spring Framework, this is achieved using Spring WebFlux, which leverages Reactor, a reactive library for building non-blocking applications. In this example, Flux is a reactor type that represents a reactive sequence of 0n items. Here, we're creating a flux that emits three names: Tom, Jerry, and Spike. The filter operator is used to only allow items through that meet a certain criteria, in this case, names containing the letter T. Therefore, the resulting flux will only emit Tom. Also, no data starts flowing until we subscribe to this flux. Overview of WebFlux Framework. Spring WebFlux is part of the Spring 5 framework that enables reactive programming and building non-blocking, asynchronous web applications. It supports the Reactive Streams API and runs on servers such as Netty, Undertow, and Servlet 3.1 Plus containers. Reactive programming is a paradigm that allows for building systems that are more resource efficient and can handle a large number of concurrent connections. The provided code snippet defines a simple router function in Spring WebFlux that handles a GET request to hello URL path. When this endpoint is accessed, the server responds with a 200 OK status and a plain text body containing the message, "Hello, Spring WebFlux." This functional programming model is an alternative to using annotations for routing and handling requests in WebFlux. Developing reactive APIs with WebFlux. Spring WebFlux is part of the Spring 5 framework that enables building reactive and non-blocking web applications and services. It supports two programming models: annotated controllers and functional endpoints. In this example, we'll create a simple annotated controller that defines a reactive API endpoint using Spring WebFlux. The code snippet illustrates a Spring WebFlux controller named Reactive Controller. It uses a WebClient to asynchronously leaf data from an external service, http:/example.org resource. The @REST controller annotation marks the class as a controller where every method returns a domain object instead of a view. It is designed to serve RESTful APIs. The getData method is mapped to the HTTP GET request on the path /data by the @getMapping annotation. The return type, monostring, indicates that it will return a single string value reactively. The call to retrieve, body-to-mono-string.class, as part of the WebClient request, converts the response body to a mono, which represents a single or none emission on the reactive stream. Reactor core concepts, Flux and Mono. In the Reactor library, which Spring WebFlux uses for reactive programming, there are two main types of reactive types: Flux and Mono. Flux represents a reactive sequence of 0 to n items, whereas Mono represents a single value or no value at all. Both of these types are lazy and event-driven, meaning that they do not start emitting items until a subscriber subscribes to them. In the code, we define a flux that will emit a sequence of strings: Spring, WebFlux, and Reactor. We also create a mono that will emit a single string value, single value. The subscribe method is called on each to begin the data flow. For Flux, this will result in printing each string to the console. For Mono, it will print the single value. Subscription is the action that triggers the emission of the elements. Backpressure handling. Backpressure is a mechanism that allows the subscriber to signal the producer about how much data it can handle to prevent it from being overwhelmed. In Spring WebFlux, which is part of the Spring Framework 5 and provides reactive programming support, handling backpressure is an integral part of developing non-blocking reactive applications. The Reactor library that Spring WebFlux uses provides ways to deal with backpressure by configuring the request amount from the subscriber's side. In the provided code snippet, a flux is created which emits a sequence of integers from 1 to 10. The log operator is used to log the reactive stream events for debugging purposes. The onBackPressure buffer operator is added to buffer all the elements that could not be consumed by the subscriber, handling backpressure by storing them temporarily. Finally, a custom base subscriber is used to subscribe to the flux. The hook-on-subscribe method is overridden to initially request only one item. With every produced item, the hook-on-next method is called, and after processing the current item, it requests the next item by calling request1. This way, the subscriber controls the flow of data by requesting items when it is ready to process them, effectively implementing backpressure. Functional endpoints routing. In Spring WebFlux, functional endpoints routing allows you to define routes using a functional programming style. This is an alternative to the annotation-based approach and offers a more explicit way of routing requests to handlers. The given code snippet defines two HTTP request handlers using the functional API. The .get method maps a GET request to the handler getUserById for the given path /API/users/ID, which fetches a user by their ID. The response is OK with the body containing the user details. The .post method maps a post request to user handler createUser for the paths API/users, which creates a new user. The body of the response will contain the created user. Both routes return a reactive type, which will be converted to a server response. Error handling in WebFlux. In Spring WebFlux, global error handling allows us to handle exceptions that occur across the entire application in a centralized way. This is typically done by using the controller advice annotation, along with a class that extends WebExceptionHandler. The provided code snippet defines a global error handler class that can handle exceptions globally in a Spring WebFlux application. It extends abstract error WebExceptionHandler to leverage Spring's mechanism for handling errors in the web layer. The constructor of global error handler sets up message readers and writers necessary for handling requests and responses. The getRouting function method is overridden to specify that this handler should be applied to all requests. The renderErrorResponse method uses the getErrorAttributes method to extract error details and construct a response with an internal server error status and the error information in JSON format. WebClient for reactive client-side HTTP. Spring WebFlux introduces WebClient, a modern, non-blocking, reactive client for HTTP requests. This contrasts with the older, more traditional REST template that uses a blocking I/O model. WebClient is designed to work with reactive applications and supports asynchronous and streaming scenarios. It can communicate with HTTP servers, sending requests and receiving responses in a reactive stream that can be processed with backpressure. Here's an example demonstrating how to use WebClient to perform a GET request. The code snippet defines a simple usage of WebClient. We first import WebClient from the Spring WebFlux package. Then, we create an instance of WebClient pointing to http:/example.com. We initiate a GET request to the /resource endpoint with .get /resource. The retrieve method is used to fetch the response. Body to mono string.class indicates that we expect the response body to be converted to a mono emitting a single string value. Finally, subscribe system.out println subscribes to the mono and prints the result once it is available. This whole process is non-blocking and reactive. Introduction to microservices with Spring Cloud. In this introduction, we will create a simple microservice using Spring Boot and register it with Eureka, a service discovery component of Spring Cloud. This code snippet demonstrates a basic Spring Boot application with a REST controller that exposes us product's endpoint. The @enable discovery client annotation marks the application as a Eureka client, which allows the service to be discoverable in the service registry. The product service application class is the entry point, while the @REST controller defines a simple controller with a getProducts method that returns a list of products. Service discovery with Eureka. Service discovery is a key component of microservice architectures, allowing services to find and communicate with each other. Eureka, created by Netflix, is a service registry that makes it easy for services to discover each other. In a Spring Cloud context, services register with Eureka Server, and other services look up the Eureka Server to find their peers. The code defines a basic Eureka Server using Spring Cloud. The @enable Eureka Server annotation activates the Eureka Server functionality. In the application.properties, Eureka.client.register with Eureka =false, and Eureka.client fetch registry false indicate that the server won't attempt to register itself with another Eureka server, which is typical for a standalone Eureka server. The server port is set to 8761, a default for Eureka. Client-side load balancing with Ribbon. Ribbon is a client-side load balancer that gives control over HTTP and TCP client behavior. Integrated into Spring Cloud, it works with Spring REST template and Feign to load balance across service instances registered with a discovery service like Eureka. The code snippet defines a simple Spring configuration class that registers a REST template bean annotated with @loadBalanced. This tells Spring Cloud to create a load-balanced REST template instance, which internally uses Ribbon to choose which service instance to call. The @configuration annotation marks the class as a configuration class, and the @bean annotation tells Spring to manage the REST template object as a bean in the Spring application context, injecting it wherever it's needed. Circuit breaker with Hystrix. Hystrix is a library from Netflix that implements the circuit breaker pattern, which is designed to allow a microservice environment to fail gracefully. When a service dependency fails, bringing down all dependent services is undesirable. Instead, Hystrix wraps function calls in a proxy that monitors for failures. Once failures reach a threshold, Hystrix trips the circuit breaker to prevent further damage and allows the system to continue functioning with fallback options. In the provided code snippet, the Hystrix command annotation marks the reading list method as protected by Hystrix. If a call to the REST endpoint via REST-template.getForObject fails, Hystrix will route the call to the reliable fallback method. This reliable method provides a hard-coded response that will be returned instead of allowing an exception to be thrown back to the client, thereby providing a basic level of resilience to the application. Declarative REST client with Feign. Feign is a declarative web service client that simplifies calling REST APIs by writing minimal code. Instead of creating a REST template and adding boilerplate code, Feign provides a more intuitive approach by allowing developers to declare and annotate interfaces to represent REST endpoints. In the code snippet, we define an interface called user_client, annotated with @FeignClient, designating it as a Feign client. The name, attribute of @FeignClient is arbitrary, but should be unique within the application context. The URL attribute specifies the base URI of the REST service we want to consume. We then define a method getUserById annotated with @getMapping to map the HTTP GET request to /users ID. GetUserById takes a parameter ID annotated with @path variable, which binds the method parameter to the URI template variable ID. When invoked, Feign will make the REST call and return the result. API Gateway with Zuul or Spring Cloud Gateway. In a microservices architecture, an API gateway is a server that acts as the single entry point into the system. Zuul, part of the Netflix OSS suite, is a commonly used API gateway in Spring Cloud, providing dynamic routing, monitoring, resiliency, and security. Below is a simple example of how to set up Zuul as your API gateway. In this code snippet, we have a Spring Boot application that uses the @enable Zuul proxy annotation to enable Zuul. This annotation sets up the application as a Zuul server. The @Spring Boot application annotation marks the main class of the application that will run with Spring Boot capabilities. Running the Gateway application class will bootstrap the Zuul proxy and make it ready to handle requests and route them to the appropriate microservices. Distributed configuration with Spring Cloud Config. Spring Cloud Config provides server-side and client-side support for externalized configuration in a distributed system. The config server centralizes the management of configuration properties across all environments and applications. Clients, typically microservices, fetch their configuration from the config server during runtime. In this context, there's no specific code snippet provided, but generally, a config server is implemented as a normal Spring Boot application with @enable config server annotation. The configuration of the server involves specifying the locations of the configuration repositories, which are often Git repositories. The client services include a dependency on Spring Cloud Config Client and Bootstrap properties to locate the config server. tracing with Zipkin, and Spring Cloud Sleuth. In a microservice architecture, tracing requests across service boundaries is essential for debugging and latency analysis. Spring Cloud Sleuth integrates with Spring Cloud applications and provides unique IDs for tracing requests. Zipkin is a distributed tracing system that collects and visualizes these traces. Together, they provide a powerful tool for understanding system behavior. By including the Spring Cloud Starter Zipkin dependency in your build configuration, your application will be equipped with Spring Cloud Sleuth and Zipkin client support. Sleuth automatically tags your logging information with trace IDs and span IDs, which represent a request's journey through your system. Zipkin then uses these IDs to stitch together a detailed trace of the request across all services it traversed. To view these traces, you would also need to run a Zipkin server. Using Spring Cloud Stream for event-driven architecture. Spring Cloud Stream is a framework for building highly scalable, event-driven microservices connected with shared messaging systems. It provides a flexible way to communicate through asynchronous messaging without having to deal with the complexity of the underlying message brokers, such as RabbitMQ, Apache Kafka, etc. While we don't have specific code to show in this introduction, understand that Spring Cloud Stream abstracts the messaging system. This allows developers to produce and consume messages simply by defining interfaces, without needing to concern themselves with the specifics of the broker's API.